So I want you to think about the last time you opened up a piece of creative software. Like put yourself in that exact moment.
Oh, I can already feel my blood pressure rising just thinking about it.
Right. I mean, before you can even write a single note of music or, edit a single frame of video, you probably have to click away some pop-up begging you to upgrade your subscription.
Yeah, or you get hit with an updated privacy policy that wants to track all your usage data.
Exactly. And then you have to sit there and wait for an internet connection to verify your digital license just to prove you actually have the right to use the tool you already paid for. It's just exhausting.
It really is. And, when most of us picture a professional grade music recording studio like the kind that can handle a massive electronic orchestration or a live jazz quartet, we immediately just picture this mountain of expensive subscriptions and proprietary hardware locks.
We just assume that's the cost of doing business. But our mission for today's deep dive is to prove that this whole restrictive ecosystem is completely optional.
Which is such a refreshing concept.
It really is. We are looking at a truly fascinating article and an accompanying video today. It's titled, A Comprehensive Overview of the Free Software Palette Available to the GNU Linux-Based Musician.
And that was produced by the Djere Services Group, right?
Yep, for Season 1, Episode 4 of the One Shot Computer Science podcast, which came out back on April 6th, 2026. And I have to say, the visual evidence they provided alongside the text is it's striking.
It really paints quite a picture of what a liberated workspace actually looks like in practice.
Yeah, the source image shows this gorgeous physical studio setup. You've got this beautiful alto saxophone resting on the desk, a MIDI keyboard just ready to go, and these dual monitors glowing in the background.
With the sheet music on one screen and the audio timeline on
Exactly.
that TV.
It looks like any top-tier commercial studio. But the kicker is that this entire setup is running natively on pop.os GNU Linux. There's no corporate giant, mediating the creative process.
And that perfectly sets up exactly what we want to explore today. We're going to guide you through this entirely open source ecosystem to show you that retaining absolute total control over your creative process isn't just some fun experiment for tinkerers.
Right. It's a mature, fully professional reality that you can adopt right now. But before we start hooking up our virtual microphones, I think we need to define our terms here because the article uses the phrase free software heavily.
Yes, and that is a very specific designation.
Right. And reading through the source text, I realized I've kind of always misunderstood that phrase. I thought free just meant the software had a price tag of $0. But the article stresses that it's actually about liberty.
What's fascinating here is that this is the most critical distinction we can make today. The Free Software Foundation defines it primarily as a matter of human liberty.
So the zero price tag is just a bonus.
Exactly, it's just a byproduct. The foundation is built on 4 central freedoms, and they number them 0 through 3.
Okay, let me see if I grasp these correctly from the reading. So freedom 0 is simply the freedom to run the program however you want, for any purpose. No company can tell you that you aren't allowed to make commercial music with their tool.
Right, you have total autonomy over its use.
Then freedom 1 is the freedom to study how the program works and actually change the code to suit your own computing needs. Freedom 2 lets you redistribute copies to help your friends. And freedom 3 is the freedom to distribute copies of your modified versions to the public.
You nailed it. It is a massive paradigm shift. Instead of renting a tool from a corporation that dictates how you use it, you own the tool completely.
That is wild.
It is. And to truly understand how this empowers a musician, we shouldn't just, list off a catalog of software. We're going to walk you through the actual chronological life cycle of creating a song.
So starting from the very beginning.
Right. We will start with the initial spark, writing the sheet music, then cross over into recording the audio, and finish up with adding that professional studio polish.
Let's jump right into phase 1 then. Getting the music out of your head and onto a page. The actual engraving of the notes. In the software world, these tools are called score writers or music notation programs.
And as anyone who has tried to write music knows, this is usually where the headache begins.
Oh, absolutely. It is notoriously difficult to translate complex musical thoughts into a standardized visual format. But the GNU Linux ecosystem has some incredibly powerful options here.
And what's really cool is that they cater to entirely different ways of thinking.
Yeah, the one that stood out to me first, probably because it feels the most instantly familiar, is MuseScore Studio. It was created back in 2002 by a developer named Werner Schwier.
Right, and MuseScore relies on what you see is what you get, or WYSIYG interface.
Which is such a brilliant, intuitive way to design it. The easiest way to think about MuseScore Studio is that it's basically a modern word processor, but for sheet music.
So if you want a quarter note on the middle line, you just click it there.
Exactly. Just take your mouse, click it, and it instantly looks exactly how it will look when you print it out. This program was a massive deal because it democratized professional music engraving.
It completely replaced those prohibitively expensive proprietary tools like Finale and Sibelius.
Yeah, the ones that used to be the only game in town if you wanted to publish, like a book of alto saxophone etudes or a full band chart.
For highly visual thinkers, it is perfect.
Hmm.
But the sources highlight another tool called GNU, which started in 1999, that takes a totally different approach.
Okay, yeah, GNU.
So GNU serves as a graphical front end for a highly respected but purely text-based backend called LilyPond.
Okay, wait, I have to stop you here. When I was reading this section of the source material, I honestly thought I was misunderstanding it. It says LilyPond generates sheet music from text code.
That's right, raw text code.
Why on earth would a musician ever want to write raw computer code just to compose a jazz solo? I mean, am I missing something? That sounds incredibly tedious.
It sounds completely counterintuitive, doesn't it? But there is a very practical reason for it. Let's say you are using a visual tool like MuseScore, and you are composing a massive orchestral symphony.
Okay.
Using your mouse to drag and drop 10,000 individual 16th notes across 50 different instruments is going to destroy your wrist. It's incredibly slow.
Oh, wow. Yeah, I didn't think about it at scale like that.
LilyPond, on the other hand, generates arguably the highest quality publication-ready typographical output available in the world. It looks like it was engraved by hand in the 19th century.
But writing raw text code to get that output is still tedious, right?
It is, and that's exactly what Dynamo fixes. Dynamo bridges the gap. It is built specifically to bypass the steep learning curve of LilyPond.
So how does it actually work in practice?
Instead of typing out code or clicking a mouse repeatedly, Dynamo lets you rapidly input notes using your computer keyboard, or even better, by just playing them on a connected MIDI controller.
Ah. Wait, really? So you just play the melody naturally on your piano keyboard and the software handles the rest?
Exactly. While you are inputting the notes at blazing speed, Dynamo is continuously communicating with LilyPond in the background, silently writing that complex, perfect code for you.
That makes total sense now. You get the benefits of the underlying code structure without having to be a programmer yourself.
Right. It combines the absolute fastest possible data entry with the highest possible visual output.
But even with these great tools, the article brings up a major historical pain point for composers, which is workflow fragmentation. Like usually you write the sheet music in one application and then you record the actual audio in a completely different application.
And never the twain shall meet.
Yeah.
It creates a very disjointed creative process.
Yeah, you end up constantly exporting and importing files just to hear how your written score sounds alongside a recorded track.
Which is where Rose Garden comes in. Its origins go all the way back to 1993, though it was heavily rewritten around 2000 to work with modern Linux architectures.
Here's where it gets really interesting, because Rose Garden is built to solve that exact fragmentation problem, right? It actually understands deep musical structure natively.
Right. It doesn't just see a timeline of abstract sound waves. It understands what a measure is, what a time signature is, and what a note actually is.
Exactly. So as a composer, you can be looking at traditional sheet music or a piano roll on your screen while simultaneously syncing up recorded audio tracks and sequenced MIDI data.
All perfectly aligned in the exact same window.
You are literally watching the written notes pass by as you hear the recorded saxophone playing them. It's magic.
And it routes all of this complex data seamlessly through two foundational pieces of Linux architecture, ALSA and JSync.
I want to make sure we understand those because they come up a lot in the sources. So ALSA is the Advanced Linux Sound Architecture.
Correct.
From what I gather, that's basically the foundational layer that allows the software to physically talk to your hardware, like your speakers and microphones.
That's right. And JSync is a specialized sound server that sits on top of that.
So how does Jake fit into the puzzle?
Think of Jake like an impossibly fast, invisible switchboard operator. If you have audio coming out of Rose Garden and you want to route it into a separate effects processor before it hits your speakers, Jake is the operator physically plugging the virtual cables into the right slots at lightning speed.
Oh, so it handles the complex routing.
Exactly. It provides the extremely low latency routing required for professional audio.
So you aren't dealing with that horrible half-second delay between playing a note and actually hearing it in your headphones.
Precisely. Which brings us to a crucial transition in our journey.
Right. Phase 2, because we have our brilliant alto saxophone etude written out perfectly. But right now, it only exists as instructions on a screen.
To make it real, you have to pick up the actual horn, put a microphone in front of it, and play. We are crossing the chasm from notation into audio engineering.
And here we have to make a vital distinction that the sources emphasize the difference between a digital audio editor and a digital audio workstation, or DAW.
Yes, this is a really important technical distinction.
The analogy that helped me wrap my head around this is to think about photography versus filmmaking. A digital audio editor is like having a dark room with scissors, tape, and touch-up tools for a single photograph.
You're working directly on the raw material.
Exactly. You can cut out a mistake, splice two takes together, or tweak the overall volume. But a digital audio workstation is like directing a massive live-action play with 50 actors on stage where you control space, time, lighting, and movement all at once without permanently altering any of the original elements.
That perfectly captures it. The editors are built to manipulate the actual audio waveforms directly. The workstations are built to manage a massive environment non-destructively.
So looking at the editors first, the heavyweight champion mentioned in the sources is obviously Audacity.
Oh, definitely. Created back in 1999 at Carnegie Mellon University.
Yeah, and it has genuinely democratized audio production for decades. If you just need to record a single track, slice out some background noise, and do some basic mastering, it is rock solid.
The sources also highlight K-Wave for users who are deeply embedded in the KDE desktop environment.
Oh, right, K-Wave. That one dates back to 1998, I think.
Yep. And it was built specifically using the QD visual framework. It is a fantastic option if you want a lightweight, seamless visual experience without a lot of clutter.
But when we talk about audio editors in this ecosystem, the article highlights a really critical piece of modern digital history regarding a program called Tenacity.
Ah, yes, the telemetry drama.
And this story perfectly illustrates why those 4 freedoms of free software we talked about earlier actually matter in the real world.
It is a textbook example of open source philosophy in action. In 2021, the original Audacity project was acquired by a corporate entity called Muse Group.
Okay, and what happened then?
Well, shortly after the acquisition, the new owners proposed introducing telemetry into the software.
And just to be absolutely clear for everyone listening, telemetry is the automated collection and transmission of your user data over a network sent back to the developers. It's essentially tracking code.
Correct. Now, looking at this purely factually from the source text, privacy advocates within the open source community immediately flagged this.
Because it goes against the whole philosophy.
Right, exactly. They saw this data collection as a fundamental compromise of user privacy and a violation of the free software ethos.
Now, if this was proprietary software, users would just have to complain on forums and eventually accept the tracking, or just stop using the tool entirely.
But because Audacity was open source, they had another option. Because Freedom 1 and Freedom 3 guarantee the right to study, change, and distribute the code, the community didn't have to accept the telemetry.
They utilized a process called forking, right?
Yes, in the software world, if you don't like the direction a project is going, you can legally take the existing open source code, copy it, and build your own alternate universe version of the software. They forked Audacity and created Tenacity.
So Tenacity gives you that exact same familiar, powerful editing environment you've relied on for years, but it strictly respects your data sovereignty.
There is absolutely no corporate tracking code.
It ensures that the tool remains completely under your control. That is an incredible, real-world application of user liberty.
It really is. Now, if your project grows beyond editing a single saxophone recording, let's say you're now bringing in a drummer, a bassist, and a pianist for a whole jazz quartet, you need to graduate from those editors.
Right. You need a full digital audio workstation. Enter Ardor, created by Paul Davis in 1999.
And fun fact, Paul Davis is the same developer who built that J6 switchboard routing system we talked about earlier.
Oh, wow. I didn't realize that connection. Ardor is the premier powerhouse of the Linux audio world, isn't it? It was built from the ground up to compete directly with proprietary industry standards like Pro Tools.
Ardor is that non-destructive environment you mentioned earlier. It gives you unlimited audio tracks, highly advanced signal routing, and unlimited undo and redo capabilities.
So it's basically the heavy lifter.
Absolutely. If you are mixing a massive 100-track, fully orchestrated arrangement, Ardor is the engine that can handle that immense workload without breaking a sweat.
But I'll admit, Opening up a powerhouse like Ardor for the first time can be pretty intimidating. I mean, it looks like the cockpit of a 747.
It can be overwhelming for sure.
Which is why the article thoughtfully brings up Q-Tractor, created in 2005, as an alternative. It's built on that same Qt graphical framework as K-Wave, and it serves as this perfect middle ground.
Q-Tractor is a highly efficient audio and MIDI sequencer. It is ideal for a composer who needs a lot more functionality than a simple editor provides, but finds a massive, resource-intensive studio suite like Ardor to be overkill for their specific workflow.
It's lightweight, but incredibly capable. Okay, so let's check in on our listener's song progress. You wrote the sheet music flawlessly, you got the jazz quartet into the room, and laid down the multi-track audio in Ardor.
But right now, if you hit play, it sounds raw.
Yeah, it sounds like 4 people playing into microphones in a garage. It lacks depth. It needs the polish of a commercial release.
Which brings us to phase 3, the polish. This involves utilizing audio plugins and virtual instruments, which run on established open standards within the ecosystem, like LV2, LADSPA, and VST.
This is where we truly shape the sound. Let's start with virtual instruments. What if our jazz quartet decides they want like a rich, atmospheric synthesizer playing underneath the saxophone solo?
The expert source points us to an instrument called Yoshimi. And Yoshimi is a truly fascinating piece of software.
Yeah, okay, tell me about it.
It was forked. There's that concept again from an older synthesizer called Zynad Sub FX in 2009 by a developer named Alan Calvert.
Now, why do a whole new fork just for a synthesizer? Like, what problem was Calvert actually trying to solve?
If we connect this to the bigger picture, the goal was live performance stability. Generating complex sounds like those rich, slowly evolving atmospheric pads or sharp percussive leads requires immense mathematical calculations.
Right, it's extremely CPU intensive.
Exactly. In a normal setup, if a background process interrupts your computer's processor for even a fraction of a second while you are playing a heavy chord, you get a stutter. The audio drops out entirely.
Oh, and there is nothing worse than being on stage, hitting the climax of a solo, and hearing your laptop just choke.
It's a nightmare. To prevent that, Yoshimi was engineered specifically to utilize multi-threading.
Meaning it splits up the work.
Exactly. Think of standard processing like a single lane on a highway. If one car stops, everything stops. Multi-threading opens up multiple lanes. Yoshimi efficiently distributes its 3 distinct synthesis engines, additive, subtractive, and pass-and, across different processing threads.
Oh, that's clever.
Yeah, this ensures that even under heavy load, your live performance remains pristine and latency-free.
That is incredible engineering. So we have our virtual synthesizer locked in and stable. Now we need to process the actual audio tracks. We need EQs to carve out the frequencies and compressors to control the dynamics.
And the sources highlight 2 incredibly popular plugin suites for this: LSP, which stands for Linux Studio Plugins, and CAF Studio Gear.
These 2 suites represent 2 very different philosophies of audio engineering, don't they?
They do, though both are highly effective. LSP started in 2014, and these are the tools you reach for when you need absolute surgical technical precision.
We are talking highly advanced parametric equalizers and multi-band compressors.
Right, and what makes LSP stand out is that it gives you this incredibly detailed, real-time visual analysis of the audio signal exactly as it's being processed.
So you aren't just hearing the saxophone, you are literally watching the exact frequency waves of the breath on the screen, allowing you to make microscopic adjustments.
It provides the transparent, exact processing required for modern professional mixing. But then you have CAF Studio Gear, which started earlier, around 2007. And CAF is famous for its beautiful skeuomorphic design.
Okay, let's unpack this for a second, because skeuomorphic is a great design term. It basically means making a digital interface look and act like a physical, real-world object.
Right, like digital leather textures or metal toggles.
Yeah. CAF plugins look like heavy metal boxes with glowing analog VU meters and textured knobs. But my question is, why does that matter? If the underlying math and code work perfectly to compress the audio, who cares if it looks like a spreadsheet or a piece of vintage hardware?
It matters deeply because musicians and audio engineers are fundamentally tactile creatures. They rely on muscle memory and intuition.
Okay, I can see that.
When you are using CAF plugins, the interactive knobs, sliders, and visual feedback intentionally mirror traditional hardware studio racks. It bridges the gap between raw, invisible computing power and an intuitive workflow.
Oh, I see. So instead of just typing a numerical value like -12 decibels into a blank text field, You are virtually grabbing a heavy knob and twisting it.
Exactly. The visual feedback triggers the engineer's intuition. It allows the musician to apply a warm chorus effect to an alto sax or a master limiter to the entire jazz arrangement simply by feeling the virtual hardware.
It makes the cold digital environment feel like a warm physical studio.
It really does.
I love that. You are getting the polished, professional sheen necessary for a commercial release, but with an interface that respects the psychology of the traditional recording
Yeah.
experience. And the most amazing part is that you are doing all of this natively within your Gene Linux system.
Let's take a step back and look at the incredible journey we've just taken through this ecosystem.
Yeah, let's recap. You drafted a complex, publication-ready score in MuseScore Studio or Dynamo. You brought musicians into a room and laid down dozens of flawless multi-track audio takes in Ardor.
You layered in a live, multi-threaded synthesizer performance using Yoshimi.
And finally, you sculpted the final mix using the surgical precision of LSP and the visual intuition of CAF Studio Gear.
The core thesis of the Djere Services Group article is undeniably proven here. Building a studio on GNU Linux is no longer an experiment for curious tinkerers. It is a fully mature, professional path.
So what does this actually mean for you as a creator? By choosing free software, you are actively stripping away the endless subscription fees that drain your bank account every month.
You are removing the arbitrary licensing locks that tell you when, where, and how you are allowed to work.
And you are eliminating corporate data harvesting entirely from your creative sanctum.
It ultimately comes down to one word: ownership. You own your tools, and you own your workspace. You have the absolute freedom to create music exactly how you want to create it, on your own terms.
And that is such a powerful realization to have. You don't have to ask permission to create art.
It is. We spent this entire deep dive seeing how free software empowers musicians to reclaim total control over their creative workspace. But I want to leave you with a final thought to mull over, one that extends far beyond music, regarding the rest of your digital life.
Oh, I like where this is going.
Think about the software you use every single day to run your life. How many of your daily creative or professional tools, your writing apps, your graphic design software, your daily organizers, your communication tools, are currently locking you into endless mandatory subscriptions?
Too many props.
How many of them are silently harvesting your telemetry and user data while you work, sending it back to servers you can't even see? If musicians have managed to build an entire world-class professional studio ecosystem completely free of corporate constraints, what other areas of your digital life are just waiting to be liberated?
That is a brilliant and challenging question to end on. It really makes you reconsider the default choices we accept every day on our computers. Thank you so much for joining us on this deep dive. Keep questioning the tools you use, keep exploring what is actually possible, and remember, you have the power to be the architect of your own invisible studio. We will see you next time.